Okay, see. So today we're going to learn about asymptotes, right? And so perhaps you've never heard that word before. Well, an asymptote of a curve, okay, for example, let's say we have this curve, okay, and so we have an fx value, right, and we have an x value over here, and as you can see, the curve, it's going to move all the way along the lines, right, but it's never exactly going to touch the line itself, right? For example, it's like closing a door, okay? So let's say I can close a door halfway every time. And so I close the door halfway, and then the next time I close it, I only can close it half of that. So I close it 1/4, 1/8, 1/16, 1/32 until it's going to close, but I can't exactly close the door, right? It's always going to remain open by just a little bit. And that is exactly what asymptotes are. An asymptote of a curve is a line, right, such that the distance between the curve and the line approaches zero. It means it gets super close. It's almost zero. The distance between the line and the curve, approaches zero as they tend to infinity, but they never touch. It only approaches all the way, and it's super close. The margins are super little, but they never touch. Okay? And so, for example, fx equals 1 over x, right? If x is 0, so when x is 0, if we put 1 over 0, we are not going to get a value. 1 over 0 is undefined, right? Because when x equals 0, there is no value. Because the curve, right, it's going to approach 0, but at x equals 0 itself, there is no y value because the curve never actually touches this line, right? And that is what we call an asymptote. It approaches very close, but it never actually touches. And so for this function, 1 over x, your asymptote is when x equals 0, right? Because at x equals 0, it's undefined, okay? And so what kinds of functions have asymptotes? Most rational functions have asymptotes. So what's a rational function? A rational function is a ratio of two polynomials. And so what are polynomials? You know, polynomials are basically terms, you know, an equation that consists of several terms. So like 2x or 3x minus 1. Okay? So for example, you know, 3x, x minus 2, 5. These are all polynomials. And so a rational function, okay, a rational function is an expression that is the ratio of two polynomials. So like 4x over 91, for example, right? And so if you see here, all these equations, x squared plus 5 over x plus 2, or x squared minus 9 over x squared plus 3x, x squared, you know, all these equations, 3x squared over x squared plus 2x minus 15, these are all rational functions, and these functions happen to have asymptotes. Not all rational functions have asymptotes, but most of them do. Okay, and so these are the kinds of functions which can have asymptotes. Yeah. Okay, so how do we find an asymptote? Okay, so from the definition itself, we know that it's going to approach that line, but it's never going to touch. Okay, and so there are two types of asymptotes. There's the vertical one and the horizontal one. It's going to approach, okay, but it's not going to touch. However, here's the key point. They're not going to touch as they approach infinity, right? But I'll get to that later. But first, let's try to find the vertical and horizontal asymptotes for the function 1 over x. Fx equals 1 over x. Okay. So fx equals 1 over x. Right, fx equals 1 over x. And so the way we're going to find the vertical asymptote is by making the denominator, which is the one at the bottom, so in this case x, equals 0. Yep. So we know that x is going to be 0. And so at 0 itself, right, at 0 itself, that is the vertical asymptote. Okay, because it's never going to touch x. And because if the denominator is 0, the one on top over 0, we're going to get undefined. And when that is undefined, that means there is no specific value, and therefore it's an asymptote. Okay. So let's say 1 over x. And so it's going to be very, very close to 0, but it's never going to touch 0. However, just to the right of 0, so we use limits, okay? So as x gets to 0, the x value is very, very small. So 0.0000001. The more zeros you have, so 1 over 0.0001, you're going to get an infinite value, right? For example, here, okay? X equals 0.0001. The limit of x to 0 plus, right? Which is 1 over 0 equals plus infinity. And if we take the negative value, when x is very close to 0 minus, blah blah blah, then you get a negative infinity, okay? That is your y value. So the closer x gets 0, the closer x gets to 0, the bigger your value, okay? And that is exactly what we see with the graph, right? As x, you see your y value is so little now, but as it gets closer and closer to 0, your y value increases, and the closer it gets, the bigger your y value, right? The same thing on the other side. The closer it gets to negative, the smallest number possible, as close as it can to 0, your y value is going to decrease, right? 1 over minus 0.001 gives you a very, 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 very big negative number. So we call that negative infinity. Okay, so this is your vertical asymptote. Okay, now what about horizontal asymptotes? Again, horizontal asymptotes, they are just horizontal. They're still asymptotes, which mean that it's the line in which the distance between the curve, okay, and the line approaches 0. The distance between the line and the curve approaches 0 means they're very, very close together as they tend to infinity, okay? So that means when they go to infinity, your x value is going to be very, very big. Positive infinity, your negative x value is going to be negative infinity, okay? And so the same thing applies. We use limits to find what our y values are at the horizontal asymptotes, okay? For example, yeah? So here we have the same thing. Limit, okay, right. Limit x close to positive infinity, which is 1 over 999999999 equals 0, right? Because if we take 1 over a very, very, very big number, which happens to be x, yeah, we're going to get a very small number, okay? Same thing for the negative type. 1 over negative infinity equals 0, right? So our y values approach 0 at the horizontal asymptote. But in this case, in this function, it never touches. In this rational function, remember, consisting of polynomials, which is 1 here, over x, right? Okay, I forgot what I was going to say. Anyways, right, it's going to approach 0, but it's never going to touch. However, there's also a myth. The myth is that functions cannot touch asymptotes. However, this isn't true. Because the definition states that an asymptote of a curve is a line such that the distance between the curve, okay, what's my example? Okay, right? The distance between the curve and the line approaches zero as they tend to infinity. Here's the key point. As they approach infinity, okay? This is as they approach infinity. However, during that process of going to infinity, it can cross the asymptote. Even horizontal ones, for example, this function here. So the myth is functions cannot touch vertical asymptotes, but some functions can, because this happens in a piecewise function. Okay, this this is the vertical asymptote because it's never going to touch here, right? However, at the value itself, we have another function which clearly touches, right? So some functions can touch asymptotes, and this explanation gets much clearer when we go to horizontal asymptotes. A lot of people think that they can never cross, you know, like this. Look, it doesn't ever cross, therefore it's never going to cross, therefore asymptotes can never cross. But that's not true, because if we look at horizontal asymptotes like this one, right, the definition states that as it approaches infinity, okay, as it approaches infinity, the distance between the curve and this line approaches zero. As it approaches infinity. That's the key point here. A lot of people think it can never cross, but that's a myth. It's a huge misconception, right? It's not true. It can cross. Like clearly it's clear. It's gonna cross and it's gonna come down. But as it approaches infinity, it's going to become very close together, right? It's like the door. You close the door, it's going to close, but you only divide it by 2 each time. You divide it, you make it half basically. Divide it by half. Yeah? But it's never going to close. There's always going to be that gap. And half of that gap, and microscopic, nano, you know, it's never going to touch. It's going to be very close, but it's never going to touch as it approaches infinity. However, anywhere between it can cross. You know, even a function like this. You know, a function like this, for example, it's going to cross multiple times, but as it approaches infinity, right, the distance between the line, the curve, and the line, the asymptote, is going to approach zero. But in between that process, it can cross multiple times. Okay? This is a pretty long video. Right. So, again, to recap, you know, asymptotes are lines, right? Lines, invisible lines, in which the curve, the distance between the curve and this line approaches zero as they tend to infinity, but they never touch at infinity. However, during that journey to infinity, like x equals 10, it can cross through that asymptote multiple times. It's just that as it nears infinity, it's not going to touch, but the distance between them, it's going to be smaller. You know, and so most rational functions have asymptotes, and the way to find an asymptote is you make the denominator zero. That is to find your vertical asymptotes, right? Your holes, whatever. And to find horizontal asymptotes, it means that very far x, right? So you put the limit x equals positive and negative infinity, the limit when x approaches negative infinity, the limit when x approaches positive infinity, and these are your horizontal asymptotes. The other way around, x when at the asymptote itself, just to the left and to the right of that asymptote, you find your values. Is it a very big value, small value, right? And that is how you find your asymptotes. Does that make sense? Excellent. Yeah. Okay. These are not the answers for all the questions out there. It's not that all functions have asymptotes of 0, 0, plus infinity, negative infinity. It depends on your function. Okay. Right. That is all. Thank you. Bye bye.